Oftentimes in mathematical operations, the order I actually do my math doesn't change my answer. For example, 2 times 3 will give me the exact same answer as 3 times 2. And likewise with 3 plus 4. 3 plus 4 gives me the exact same answer as 4 plus 3. In problems where we have more than one math operation, the order we actually do our math starts to matter. For example, I have two ways of viewing this problem. I can either see it as 2 times 3 plus 4 times 5, which would give me 6 plus 20, or 26. Or I could view this problem as 2 times 3 plus 4 times 5, which is 2 times 7 times 5, which gives me 70. So depending on whether I do my addition or multiplication first, I get dramatically different answers. Because of this, we need to have some standard order that we're going to do our math operations. You may have learned this as PEMDAS, or Please Excuse My Dear Aunt Sally, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. That is the order that you would do your math operations. So, parentheses first, then exponents, then multiplication and division, and finally you would do your addition and subtraction last. So in this problem we actually have several math operations. According to PEMDAS, our first job is to look at the parentheses. Inside the parentheses, we have a choice between subtraction and exponents. According to PEMDAS, we do our exponents first. So we can rewrite the problem as 5 minus 4, which gives us 1. Then we rewrite the problem as 3 times whatever we got in the parentheses, which in this case was 1, plus 4 squared. Again, according to PEMDAS, we take care of our exponents before we do our multiplication or addition. So we rewrite the problem as 3 times 1 plus 16. Then we take care of our multiplication. In this case, we're multiplying 3 by 1, so it doesn't change the answer, but you would still do your multiplication before your addition. So our problem becomes 3 plus 16, or our final answer is 19. When you're multiplying across parentheses, and inside that parentheses you have either an addition or subtraction sign, you have to remember to do what we call distribution, where you multiply the 3 in this case times both the x and the y. So in this case our final answer would be 3x minus 3y. When you're multiplying with a negative number across parentheses, you have to remember to distribute the negative sign as well as the whole number. So in this case we're going to multiply negative 2xy times a positive y and times a negative z. So our final answer becomes a negative 2xy and then a positive, because a negative times a negative becomes positive, so a positive 2xz. The opposite of distribution is factoring. With factoring, we look at common terms that are on both sides of the addition or subtraction sign, and then we pull them out. So in this case, we can see that we have an x on both the left and the right of the addition sign. So we can pull out the x and rewrite that equation as x times y plus 2z. You can see that if I were to take the parentheses and use distribution by multiplying my x times my y and my 2z, I would end up with xy plus 2xz. So we really haven't changed the value of the original equation. It's just two ways of writing the same mathematical statement. Sometimes when you're factoring whole numbers, you'll have to break down those numbers to truly see what you could factor out. For example, 6a, you could rewrite that as 2 times 3 times a. 3b, well, because 3 is prime, you really can't break that down anymore. So that just stays 3b. But 12c, you could break that down into 2 times 2 times 3 times c. Now we see that each value has a 3 in it, which means we could factor out or pull out a 3 and rewrite my equation as 3 times 2a plus b plus 4c. Again, I haven't changed the value of that statement, I've just changed the way it's written.